Well, thank you all. This is the sermon slot, so if y'all would please open your browsers to https:// well, we're not going to do that. There will be no communion today. I've been told that the Holy Sacrament of Fireball would invite persecution, so we're not going to do that. And that's as religious as I'm going to get today. Disassembler preference frequently becomes zealotry among reverse engineers, and I'm here to talk about more inclusivity in disassemblers and not proselytize. So we'll leave it at that. So I'm Ben. I know some of you already know me. I have done a few workshops around here. Just moved down here with the family here in December, or this past December, from the DC area. I've been doing RE at Booz Allen for about 10 years, almost 10 years. It's a really long time. Booz Allen's been really good to me. It's a pretty cool company. That's as much advertising as I'm going to do today. If you want to know more about Booz Allen, just come catch up with me here or at any of the other local events. I've been teaching reverse engineering for quite a while, 5 years. And so I've been also been doing workshops at B-Sides, somewhat local to here, right? B-Sides DC, B-Sides Charm, up in Baltimore. I've also taught or co-taught undergrad reverse engineering at University of Maryland College Park, and of course here at DC 919 and ISSA last month. So a little bit more of my background: electrical engineering, physics from Clarkson University. Anybody know anything about Clarkson? Did my master's almost 10 years ago at Johns Hopkins, and this fall, go Wolfpack! I'll be starting my PhD at NC State in computer science. So I'm pretty excited about that, and that's about it for bio. Standard disclaimer, right? Everything presented here today, especially the rants, are mine and not that of anybody else. So let's get down to it, because I have a ton of slides, and I was going over it last night. I do tend to ramble, as I'm doing right now. So we're going to get through this pretty quickly. What is Ghidra? Why do we care? The awesome flame animation. Trust me, I didn't do it for all the slides because that would have been super lame. But what's Ghidra and why do we care? What's a good all-purpose reverse engineering tool? And how does it kind of stack up against the ones that you're familiar with? And along the way, we're going to eliminate some of the ones you're probably or maybe familiar with just on their merit. So is Panatrax here? I guess not, or not yet. I am going to crap on Radar or Radare a little bit, but it's a great tool. It's got a lot of really cool features. But we'll get into that. So what is Ghidra? How many folks have actually used Ghidra or played around with it since it was released here in March? A handful. So it's a disassembler and decompiler for analyzing binary programs. It was released and open source by our friends at the National Security Agency earlier this year. And it's a pretty awesome tool. It's robust, it's mature, it's been around. I think some folks were digging around in the source code repo and found references back as far as, I think, 1999. So it's been in development for quite a long time, probably around the same history, or kind of developed in parallel with IDA. Most everybody's familiar with IDA, right? We talked about IDA earlier. Well, a handful of talks have talked about IDA and Binary Ninja. It's developed in Java. Any Java programmers out there? Handful, yeah. That's my reaction too. I don't really love Java. It's a pretty big, for lack of a better term, it's a resource-heavy development language, and Ghidra itself, when you run it, it's pretty resource intensive, and you're trying to do binary analysis, which is also a pretty in and of itself, without the overhead of the programming language, is pretty intense. The decompiler, so the thing that everybody's really excited about, is actually written in C++, and it's pretty That's actually pretty fast. So I'm going to assume that it's named after the three-headed dragon Ghidra. Is anybody familiar with that? It's like an older, an older like version of Godzilla. Yeah. So that's the main part of it. And I guess I went backwards. So let's.
Just want to see more flavor.
That is true. It's pretty sweet. So why do we care, right? The barrier to accessing using RE tools is really high, which also makes it really hard to learn, right? So it's typically been, it's been expensive to get into. Anybody personally paid for an IDA Pro license?
You got to get that free student copy.
The free student copy, and we'll talk about that in a minute. But it's usually pretty expensive. And there is actually a free student version that was released, curiously, around March of this year. Totally not in reaction to any sort of competition or anything like that. But free and open source tools are not usually professionally maintained. They can be arcane and lacking important features. I'm not going to call any tools out or anything like that. I do like to crap on Radar, but I do use it. So it's pretty. It can be pretty tricky to get in there. So Ghidra is it's free and open source, and it has a feature set that's really getting close. That's really close to the best tools that are out there. IDA Pro, your Radar, your Binary Ninja, which is in development and is pretty awesome, but it's in its very early development. A commercial, just as like a side note, if you wanted to get the full feature set of IDA Pro, with the discounts that you get for getting multiple platforms and multiple architectures, you run about $14,000. So it's pretty cheap. It's pretty, it's not something you're gonna, you probably have to get a loan to finance that on your own. Binary Ninja is a little bit cheaper, around $600 for the Pro version, and the student version is like $150. And there is a free version of IDA Pro that they just recently released. That's last year they updated it to IDA 7 for the free version, but it of course has a lot of the features taken out, and some of the licensing can get to be a little bit weird. But as it stands, like I said, Ghidra is sort of torching the market right now. So almost immediately, IDA announced a free academic version. I don't know if anybody's looked into the terms that come along with that and how you'd actually get it, but it's not really that free. And like I said, they'd already updated the freeware to IDA 7 in last year, probably in response to Binary Ninja. And the latest freeware just added debugger support, curiously, in March of 2019. So that's kind of interesting. And Ghidra's presence is definitely going to impact all the licensing and how these companies build these tools and license them going forward. So that's pretty interesting. My talk was also burned. I was originally just going to do like an intro to Ghidra and do kind of like a little hour-long hands-on workshop, and it turns out that some guys just did a really awesome presentation at Infiltrate. Anybody been to Infiltrate in Miami? Like one or two. I highly recommend if you're interested in offensive security. Infiltrate is probably one of the best conferences you can get to. High quality content. It just really is. It's just really awesome. But at any rate, Alex Blazel and Jeremy Blackthorne did a really awesome workshop. I think it was almost 2 hours long, going through the feature set of Ghidra and going into a lot of depth. It's awesome. You should watch the video. Check out the materials. Links are here, and we'll publish the slides. And everything later. Really great video, and I was like, man, what am I going to do? So I said, well, I'm just going to approach it from the perspective of an experienced reverse engineer, and how does it kind of fit into the tool set, and how does it compare, and where might you gain some traction with your reverse engineering. So in order to do that, we need to talk about like what a good reverse engineering tool is. Well, you need a disassembler, right? It needs to be able to take the binary code and get it into some representation that's human readable. We can't all read machine code. We might memorize some opcodes here and there, but it is not expected. There needs to be some level of interactivity. How many people have used object dump, like the Linux utility, right? It's cool, you can see the disassembly, but you can't interact with it in any way. So it's not a great reverse engineering tool because you can't add your knowledge to that object dump text dump very easily without dumping it to a notepad and adding your information in there. So we want something that's interactive that we can sort of annotate with our reverse engineering knowledge that we've gained. We want to have type definition and propagation, and don't worry if those terms are not quite familiar to you. We'll go over that in depth and why it's important in a little bit. Library recognition is really interesting. It's another sort of arcane thing that you don't know you're missing unless it's not there, and then you're like, man, what does this function do? What are its arguments? Things like that. So it's a very useful feature to have. You want to have an API for automation and what's increasingly becoming more popular, program analysis. And you want to have a decompiler, of course, with IDA. And I'm going to caveat up front, all of my comparisons to IDA are without the decompiler because I actually don't currently have a decompiler license. So it's not entirely a fair comparison today. So you want to have a decompiler, if possible. You want to have a dynamic analysis interface. So you want to be able to sync, if your tool doesn't have a built-in debugger, you want to be able to at least synchronize information from a debugger that you're running into the disassembly so you can see how that's working. So that's really useful. And you want to be able to maybe do some emulation or some tracing of the program that you're looking at. And you want to have lots of architectures. This isn't necessarily a feature that you need if your job only has you focused on, Intel 64-bit malware, then maybe a tool that just does Intel 64-bit is good enough for you. My history has been that I've done a lot of firmware reverse engineering, so I've seen lots and lots of different architectures. So having the flexibility to jump between architectures is really useful. And community is really good, right? Because these tools, they're a very niche feature set and skill set, it's great to have a community around them and a set of existing examples and blogs and things like that to be able to jumpstart or learn about techniques and tools that are, or extensions and things like that that are out there that might be useful. So here are the dragons. Anybody know this one? Binary Ninja, fairly new. It's only been out for about a year or so. We all know that one, right?
Oh, I'm sorry, IDA Pro.
IDA Pro, yes.
Professional paid-for license.
Anyone know that one? Hopper. It's kind of it doesn't scream disassembly unless you look at that bottom corner and see recognize some x86 mnemonics. We all know that one. Yeah, cool. And Ghidra. Oh, look, more flames. And what about that one?
No.
Anyone know that one? It's called Jeb or JEB. It's a little more. I think it's a little bit more recent of a tool. Its licensing is kind of similar to IDA Pro, and it sort of grew up, I think, for analyzing Dalvik and Android stuff. But they now say that they support everything. So at any rate, here's the sort of the family of disassemblers that I sort of considered for this talk as purpose for comparison, and we'll set up why I kind of eliminate half of them. So Radar, as illustrated yesterday by Panatrax, lots of handy utilities. They have some philosophical things that are really interesting, and I think hampers their ability to make a better tool, right? So the command line will always be superior to everything, and there's a reason that IDA Pro is really popular. It's interacting with a graph and a disassembly in that way is it's just easier, and it's easier to really do that kind of stuff. If you're a command line nerd, it might work well for you. Documentation is in C, right? There's not a whole lot of documentation in Radar, and the few times that I've tried to interact with the community to fix bugs, and I'll kind of show an area on the next slide where it didn't work. They've been kind of hostile, which it's not very good for an open source project. There was a case a couple years ago where they weren't disassembling jump tables very well, and so I said, "Hey, jumped on an issue," and I was like, "Hey, can you point out where the code is, and I'll go fix it?" And because I didn't want to spend 3 days figuring out where it was in their code base, and they said, "Well, the documentation is in C." So all right, that's cool. I would like to help, but I'm busy, and I think I could fix it really quickly if you just told me where the code was. And they said, "Documentation is in C." I was like, all right, well, I guess you don't want help. And it was funnier at the time because I don't know if any of you know, a lot of the core developers for Radar are French. So if you think about, documentation is in C, now go away, or I shall taunt you a second time. That it lights it up a little bit, right? Yeah, something like that. But it's a free tool, right? So you've got to be grateful at some level that it exists. And there's really cool tools in the tool set. I use Rabin2 and Rax pretty regularly instead of things like readelf and object dump and things like that, if I'm looking for really quick information. So it does have its place, but as my daily disassembly driver, it just doesn't work for me. Huge learning curve to get really good with it. Little things like that you really want to see is like type propagation and things like that, not implemented very well. So it's going to be really hard to see, but it's as good as you can do from disassembly, right? So this is a program that I wrote, a really simple, stupid hello world calculator, and so on the left-hand side is the disassembly, the graph view, using their Cutter GUI. So they developed a GUI, but it's not particularly interactive. You can jump around and navigate very well with it, but using it to actually apply types and do things that you want to do as a reverse engineer, it's not there yet. I know it's actively being worked. And then on the right is I'm not 100% sure where they get their decompiler from, but their decompiler is whack. Here's this jump table, and where the disassembly happens or the decompilation happens down there, and it just says what this is supposed to be is a switch statement, right? We all know switch statement in C, and it decompiles it into a do while loop with question marks. What? They don't claim to be a decompiler. They just say, I think they use a third-party one that they sort of implemented there. But this is a case where, if you're trying to trust a decompiler to tell you what's going on, this isn't going to help. And this is very simple code typically for a decompiler to handle. Hopper originated as a Mac-specific tool, expanded to Linux, might work better on Mac, iOS, pretty good. UI does have a debugger interface, and it's fairly inexpensive at $99. For me, again, the decompiler failed pretty miserably in some cases. This is the same example. Note the graph is much smaller because it couldn't figure out how to disassemble a jump table. So that jump RAX, it should have said down here where we see that IO standard in use, it should have recognized that there's a jump table there and actually disassembled more code. And if you see what happens over here, it gets pretty close. It knows that it's dereferencing an address and setting it to RAX, but it doesn't involve that with the control flow of the program. So that's kind of a unforgivable error if you actually want to use either the disassembler or the decompiler part of this. And then another very similar case, this is the CMU binary bomb. Has anybody done that? If you've done a workshop with me, you've probably seen it. It just sort of misses the data reference. It's a jump table, so it doesn't disassemble properly. And this is Jeb. I don't have a whole lot of experience with Jeb, but I heard from a few people that it's good for things like Android RE. They claim to handle anything. Supports a handful of languages. The decompiler is IR based. We'll talk about intermediate representation a little bit later, but that's really important for doing decompilation. Similar to Hopper, it might just be best to use for Android reverse engineering at this time. Here's kind of an example. Again, the same sample code that I wrote for this little calculator with a little switch statement that handles the different operations, right? There's where it got in the decompilation. It's like we're gonna jump, but we don't know where. All the data's there, and it got really, really close to finding it, but it wasn't quite right. This might have something to do with it. All of the jump targets got disassembled as subroutines and not part of that function. Without knowing exactly how their disassembly routine runs, it's pretty hard to tell why their decompilation went bad, but it is definitely wrong. So thumbs down for Jeb. And this is kind of how I made my evaluation. If it doesn't do very basic things that I need it to do, then I'm just not going to use it because I don't have time to fix the tool. And in many of these cases, I couldn't figure out how to from the tool actually fix where it was going wrong. Or I just went on living my life and using the tools that I was familiar with. So we're back to our tools, and we're going to eliminate those three, and we're going to stick with Binary Ninja, IDA, and Ghidra. The nice thing about all these is they're cross-platform, so you can run them on any platform, except with IDA, you have to pay for that luxury. It costs a lot extra. They give you, I think, like a 10% discount between platforms, 10 or 25%, but it's still pretty expensive. That's one thing that I hope IDA does in response to all this competition is like, you know what? Yeah, you can run it on any platform you want. That would be really nice. Really nice to them, and it would probably help their bottom line at some point in the future. So now we're going to kind of talk about all the different features and how these three tools compare in terms of disassembly and how they work. And this one I'll speed through pretty quickly. The disassembly, this is what's called a linear disassembly view. They're very similar in terms of how a linear disassembly is presented. You want to be able to see your stack variables that the disassembly found, and then just sort of show the decoded instructions in a linear view. Very similar. There's almost no difference. The only real difference is that the level of interactivity between these three tools is slightly different, but you can almost always get the same things done if you need to. They all have graph views, which was a paradigm that IDA introduced and makes it much easier to follow control flow than staring at binaries. So Ghidra's is pretty similar to IDA's, is pretty similar to Binary Ninja. And on the right, Binary Ninja, that's an entropy graph, I think, that they just introduced, which is pretty neat. So now we're going to talk about how to train your dragon, and that is a very convenient movie title, right? What we want to be able to do, the sort of the thesis for this next section is talking about how we can enhance our disassembly, and in many times enhancing disassembly with data types and structures and things like that will actually improve how the disassembly runs, or how the disassembly looks, and how the decompiler works, especially in the case of Ghidra. Ghidra is actually very heavily biased towards using the decompiler view because it's so good. But there are a few things that you have to be careful about, like committing variables back to the disassembly view. It can screw things up a little bit. Ghidra's listing view isn't quite as interactive as Binary Ninja's and IDA Pro's, but those are the main points. So type definition and propagation are pretty important. Ghidra and IDA and Binary Ninja, they all have the ability to add custom types. So if you reverse engineer your code and you see, all right, I think there's a structure being used here, or this particular offset response is an array of characters, or it's a string, or something like that. You can add and import custom types, type defs, and structures, and this is really important because compilation, getting down to that machine code, throws away a lot of those high-level language constructs. So this helps document your efforts, right? So you're adding annotation, you're adding meaning to that, meaning back into the disassembly, and it can greatly enhance your analysis of decompilation. So this C structure is something that we're going to talk about for the next few slides, and the full source is at that link. Like I said, we'll make the slides available. But it's really just a really simple, dumb calculator program that takes arguments from the command line, converts them to integers, and then performs some math operation on them. If you haven't used Compiler Explorer, so if you've been in any of my workshops, you definitely have. Compiler Explorer is awesome. That's what's at godbolt.org. It's a really awesome tool. So to be able to add new data types in Ghidra is pretty simple. There's a handful of different windows that are by default. The one on the bottom left is the data type manager. So for this one, there's 3 type libraries that show up initially. One of them is like the built-in types, so for your system, like your integer, your character, your floating point types. And then there will be one that has types that are specific to the target binary you're looking at. So my target binary is called calc with struct pointer. You can kind of see it hiding there behind that menu that I've popped up there. And then there's another one that belongs to the C runtime. So if it can detect, so if Ghidra detects that your program is using the C runtime, it'll say, hey, we can import types that belong to the C runtime and try to apply them automatically, or use them or have them available for use. So you can basically right-click on your target library, and if you want to add a new type, so you right-click and add structure. You can add type def. You can add an enumeration, which makes things much easier to read. So the structure editor comes up after you've clicked add structure. There's a lot of different ways to get the same results, so this takes a little bit of experimentation to get comfortable with, but once you do, it's no worse than doing it in IDA. Has anyone ever tried to create structures in IDA? No? Well, handful of folks. IDA's structure editor is kind of crappy. Ghidra is much nicer to work with, but it takes a little bit of practice to get a handle of. So I usually start by setting the size of the structure, set the offset that I want to define, cycle through the sizes. So our first thing I want to set to a byte, and then at offset 4 and offset 8, we have our number 1 and number 2 that are in the structure. Then you can set the member names of the structure, and then set the actual name of the structure. And then you save it, that commits it back to the database, and then you can actually use it in your program. So you would go and there's our completed structure. So we have an operation, num1, num2, named it math op, and it's pretty easy to use. And now it shows up in our math op. You can actually import header files and things like that too. So if you want to import data types that way, it's a little less straightforward than this, but I put in a short little guide here to do that. It's useful. Their parser is not great, but neither is any other tools. So I would say it's on par with doing this importing via header file in Binary Ninja or IDA Pro. Again, you can also create type archives, so you can export type information from your database. So if you want to port it into another database, it's pretty simple to do. IDA's structure view takes a lot of practice. So that little red blob is in the red box is in the original IDA view. You have to right-click or press I or whatever in the structure view to bring up the structure editor. You add the structure, and then you have to do this really annoying dance of adding one field at a time with the keyboard. And if you don't get it right or you have to rearrange it, it's pretty much better to just start over. So it's kind of an annoying workflow. It's convoluted. It takes a lot of practice, and it will frustrate you at first, and probably continually. So eventually, you get down to, hey, we have a structure. It's defined in our structure window, and we can now apply that in different places. And just like with Ghidra, you can import it from a header file. Binary Ninja, it's actually really easy. You can open up the type view, which is a little button down at the bottom. Caveat: the reason I'm not doing this live is that these tools tend to have they're very finicky when it comes to displays. You might jump off the screen or the actual rendering stuff that they use. These guys are reverse engineers. They're not necessarily UI programmers. So it can get a little fuzzy, and it usually doesn't demo well. Note to self, future reference, I'll do videos. I see a lot of people doing pre-recorded videos, so that's useful. But at any rate, this is pretty easy in Binary Ninja. It brings up a little C type editor, and you can just type in your structure and hit create, and it shows up in the structure editor. So now we have all these types that are really useful, and we can apply these to the binary. So type propagation is what's the natural, sort of the natural part. The follow on to this is, now that we have these types, we want to apply them somewhere where it means something in the binary. So it helps accelerate your reverse engineering once you've identified where it's used and applied it. And it's really nice if your tool can grab onto that and say, now I can apply this type in other places in the binary where I can see it being referenced. And this is not as simple as it sounds. And it's much easier if your tool has some sort of data flow analysis capabilities. IDA by default does not. Ghidra and Binary Ninja do, and we'll talk some more about that later. But in IDA Pro, you really can just right-click on the function name. So we know that, so if you were able to look at the source, we know that this calc function takes a pointer to a math operation, which is our structure that we talked about before. So you can just right-click on it, say, all right, I'm going to set the argument, and IDA nicely goes in and propagates that data backwards. You might want to apply that structure to a place where, if you've created a local variable on the stack, and you want to apply that on the stack and then see that propagated throughout your binary, you can go to the stack view, and you can right-click on the variable, and then you can say set type, and then you're going to be sad because IDA does nothing. And they intentionally do nothing, and when I talked to the IDA developers on their forum, they were like, yeah, it doesn't do that, that's really hard. I said, it can't be that hard, I'm going to try to do it. And then I went on living my life. I don't think we'll have time to get into that one, but I messed around with it for a good day, and there just isn't the API in the base IDA version to make this any sort of an architecture-independent solution. It'd be very dependent on the actual architecture that you're running. But once you've applied that to the function, so here's the main function that actually calls calc, you can see that IDA propagates that information backwards from the function argument. So it says, I know that that RDI comes from REX, and so RDIs are arg1 in x86. I'm going to propagate this backward to this local variable, and then I'm going to apply the structure offsets in the disassembly. Pretty handy. So now you've declared that type, and you can see all the places where that type is being used, and it's pretty handy. But not so much in the forward direction. So this is inside the calc function. I've applied the type to var18 and said, hey, var18 is a math op pointer. Please help me out and apply this everywhere that you see var18 used, and not so much. So you have to go and individually apply that to all those places where you see var18 dereferenced and then used in order to get that context. So that's what I was trying to automate a little bit, and then then I had to finish my talk. Binary Ninja. Binary Ninja is pretty much the similar, right? You set the function or set the type for the function, and it nicely. Binary Ninja, because it's data flow based, they actually do forward propagation from the argument. So you can see in that highlighted line, it's forward propagated that argument and said, hey, this particular reference is accessing math operation, which is really handy. They actually don't do backwards propagation. It's a known issue. I assume they're going to fix it, but in this case, you can actually apply the type to the stack variable that you know is the math operation, and it does help you out. So you can see where the arrows are being drawn. It says, this var18 I know is a type math op, and I'm gonna apply it there. So it actually works out nicely. They do have it. This is a known issue, and I think they will fix it at some point down the road. But they're actually actively working on their intermediate languages to arrive at a decompiler. So it's a little bit lower of a priority. So here's Ghidra before the type's applied, and this is where we're actually really going to see some cool fix-ups. So here's our calculator. Here's a Ghidra initially decompiles our calc function and our main function, which it's kind of readable, right? Like if you stared at it long enough, it looks like valid C code. It doesn't look really screwy. There's a few extra things there that might throw you off a little bit, but if you think about it and you stare at it long enough, it could make sense. But what we want to do is we want to apply our type that we did, just like the type that we made, just like we did in the other two examples, to Ghidra. So you can go in, you can edit the function signature. You can go in, you can fix it. There's multiple ways to do this. You can go in and actually change the function variables, or you can just do it in that little white box at the top and write it in. So I've updated it there, and at the end we have our function prototype that's actually accurate. Once you hit OK, and you're effectively applying this to the function prototype, this is what it looks like afterwards. So pretty close to the actual source code. So we can see our pointer dereferences. The only part of the source code that isn't exactly right is that little temporary uvar1. The actual C code has input to op being called inside the switch statement, but it's just making its own temporary variable there. And look at how well main has cleaned up. It identified that structure was local to main, and then cleaned it up. So this is almost, actually, yeah, you could probably copy that out and compile it pretty easily without much if any modification. The only thing you might have to modify is main. Further tidying up Ghidra, there's an enumeration in there that represents the different opcodes for the operations for our simple calculator. So I've gone in and added an enumeration, and we can go there, apply that, and there's a conversion function that spits back the actual opcode from the string that was passed in on the command line. You apply that type appropriately, and it cleans everything up really nicely. And it cleans up automatically once you've fixed that in the function prototype. It applies it everywhere else, so it propagates it really nicely. And now we have almost exactly the C code that was written. And if we tidy up main a little bit by saying, all right, well, main, it's a traditional main, right? argc, argv. You do that, and that's pretty much exactly the source code, which is pretty rare. And this is a very simple example. It's probably never ever going to be this easy, but it just goes to show the power of recognizing data types and being able to apply them to your disassembly, and how much that can improve your disassembler and decompiler output. So it's pretty neat. So this is what Dracon has to say. That was the coolest dragon pun I could come up with. It took me a long time to find a middle part of that meme, so it was cool. So so at any rate, of course, I'm being unfair to IdaPro here because I don't have the decompiler package, and at some point maybe I'll beg my bosses to get me one of those licenses and look at that. But there are a few more really important things that we'll have to breeze through because I'm probably halfway through my slides with 10 minutes to go. External code signatures. So you want to be able to have import signatures. So what does this mean? So if your program calls an external API or calls an external library, typically those are well-known libraries. So like your C library or your networking library or things like that. You want your disassembler to recognize those function calls, and then propagate that information to annotate your disassembly. Both Ghidra and IDA ship with a lot of built-in type libraries that you can use. And like I said before, Ghidra's data type manager you can use to import and export, and IDA has utilities to do this as well. Binary Ninja devs are working on this feature. I think it's coming with the next major release. They do make up for it a bit because they do a lot of type inference based on their data flow and their analysis of the disassembly. So in some cases, they're able to actually infer what those function prototypes should be based on how they're actually used. But if there's a custom data type, that can be pretty difficult to do. And like I said, these are features that you don't miss until they're not there, and you're like, man, I know this is calling N2H, like why isn't it showing me the propagating these arguments backwards, because it doesn't have the type library for it. Function recognition. So recognizing these imported functions, Ghidra, it's kind of hard to see over there, it recognized A to I, and it recognized that type library, applied it in the binary pretty nicely. IDA does this as well. This is based on, I didn't put that in there, IDA says this is in my type library, I know what A to I looks like, and I'm gonna apply that everywhere that I see A to I called in the binary. So it's really helpful to not have to manually do that. Binary Ninja, you can see it kind of just infers what the return type is. It doesn't know, it doesn't have any type library to reference and say, all right, well, I recognize this symbol A to I can apply this function signature to it and propagate that information, but it is coming. Inline signatures, so Binary Ninja, Ghidra has a function ID plugin that uses some complex math to identify statically compiled libraries and where they're linked in. IDA does this with the flirt technology. Binary Ninja, again, it's planned but not a priority. Does a decent job of inferring prototypes and things like that. Anybody know this one? What is it? But what is it from Skyrim? Force push. Anybody know the actual name?
Dragon something.
Unrelenting force. All right, you'll get a Ghidra sticker at the end. Fuzroda. Nightmares. Yes, from Skyrim. So more nerd references. So extending, right? Ghidra is open source, so you can extend it. Extension is done with Java, Python, and SLEIGH, and we'll talk a little bit about SLEIGH a little bit. It ships with a ton of supporting an example script, so there's a lot of stuff there for you to do or to fall back on in terms of developing analysis tools and extending Ghidra. Plugins require the Eclipse IDE to develop, which is a little bit clunky. I'm hoping somebody will port that to JetBrains or some sensible IDE. And SLEIGH is used for adding, extending, creating supported processor architectures. It also has the concept of a tool, which is multiple plugins put together to perform a task. Extending IDA Pro. Pretty simple. They have a C++ SDK. They have IDC, which is a custom C-like language that exposes their API, and then they have IDA Python, which everything has the ability to use Python, and everyone loves Python because it's very easy to rapidly prototype things. But it's pretty useful. Unfortunately, the free version of IDA does not expose Python. You can only use IDC, so that's kind of annoying. Another thing that I hope that they change in the future. Extending Binary Ninja, pretty much the same. They have a C++ API. They are compatible with Python 2 and 3, and most of their community plugins are pretty much done in Python. So any example of something you want to see, they actually have a pretty big community repo, and we'll talk about that in a few minutes, for figuring out how to do scripting in IDA, or Binary Ninja. Learning the APIs, right? It's great to do with it's easy to do with Python. It's easy to work with, and you can rapidly prototype things. It's obviously slower performance, so if you need to have something that's performant, you may want to port that to C++ or Java, whatever's native to your specific platform. Program analysis is becoming really important. We want to lift binaries to the assembly language or an intermediate language or representation that represents the actual semantics of the program. So if you look at the disassembly, you don't always know from the disassembly what that instruction, what those instructions are doing. There's a lot of inferred things that happen. So you need the decoding, but you also need the semantics of the instruction. This is becoming popular because it's a really good way to hunt for bugs and actually prove properties about programs. It also enables you, if you can lift to a common intermediate representation, and it allows your analysis tools to work across multiple architectures. So something you write for x86 could work for ARM, could work for MIPS, could work for RISC-V, whatever you're interested in reverse engineering. Ghidra and Binary Ninja are engineered for program analysis and include these ILs in their base distribution. So it's really, really helpful for that. IDA, you got to pay. It's another thing. I hope they change this. Their Microcode IL, they recently released it, but you need a decompiler license to actually access that.
Can you define IL?
Intermediate language. So intermediate language, intermediate representation, kind of interchangeable. It's basically expressions that are translated from the binary code that fully explain the semantics of the instruction. Ghidra has this thing called P-code. So P-code is their intermediate representation. It's side effect free. It's a lot of documentation on it. Each assembly instruction is translated into one or more P-code operations. And you can enable this from the listing view if you're in there. The tiny little thing up there in that box will open up this customization thing, and you can display the P-code. And so on the right is the P-code. It's not particularly human readable, but it is very precise, which is what you need to be able to do analysis. IDAPRO's Microcode, they've done a few talks on it. You require a decompiler license, so I can't go too much into that. Binary Ninja has several levels of intermediate languages at different abstraction layers. They're designed to be human readable. They're designed to be analyzed programmatically. So they get closer and closer to source code. Low-level IL is the first level. It's the first step up from assembly language. Medium-level IL, they start to infer types and resolve stack variables to actual variables, and it removes dead stores and things like that. The high-level IL, which is coming soonish, maybe by the end of this year, will actually be really close to a decompiler. So it'll have expressions that look a lot like a high-level language. And this is kind of what they look like. On the left, here's our assembly language. Here's our low-level IL, which you can see it kind of change a little bit. And then our medium-level IL, getting closer and closer to C-like expressions. And it's actually a little bit easier to read. When I use Binary Ninja, I generally jump right to the medium-level IL if I'm trying to figure out what's going on. And you can cycle through those if you have Binary Ninja with the I key. So it's really easy to cycle through on your display. Dynamic analysis, not a whole lot to say here. IDA has the most robust dynamic analysis if you have that enabled, or if you have a full IDA Pro license. Ghidra has that's in development. There's a tool called GDB Ghidra that was just released this week. That is not exactly a debugger, but it will sync information from GDB back to Ghidra. I have not tried it myself. I just saw it floating around on the Twitters. I was like, oh, I should add that to my talk, and if I have time, try it out. Binary Ninja doesn't have it natively yet, but there are folks that have developed plugins that will interact with different debuggers like x64 Debug or Voltron. And that's about it. Architectures, right? We want lots and lots of architecture support. IDA Pro supports the most by far. IDA and Binja devs will implement new targets if demand is high enough. They're all extendable to support new processors, but it varies a lot between tools. The one really common part is understanding the instruction decoding. So you need to be able to read a processor manual to be able to do this. Ghidra's SLEIGH is actually its own language and compiler. It takes the SLEIGH specification and it uses that SLEIGH specification to decode into those P-code things that we saw earlier. And the nice thing about the P-code is the SLEIGH language is it describes the semantics of the instruction such that you can translate it into the SLEIGH compiler can translate it into P-code. Lots of documentation on this, and there's actually quite a few examples coming out now. Here's kind of an example. So you want to declare an address space, registers, and then the set of registers for the program. Then you sort of define the decoding of the instructions, so what the different bit fields mean. These can overlap depending on how many different decodings of the instructions you have. Then you attach the tokens that you defined over there to the actual registers that they're valid for, and then you can start describing the actual instructions via the mnemonic. So the top part describes the decoding, and then what's in the brackets actually describes the semantics of that particular instruction. This is obviously a very, very simple example of a PowerPC instruction. They can get really, really complex. IDA Pro, you rarely have to do this, but when you do, it's a lot of work. There's you have to really. Most people are doing it in Python now, but it's definitely quite an undertaking because you have to develop an emulator, you have to develop an analyzer that analyzes the decoding, the emulation, which basically gets you the semantics, and then you have to you talk about developing code for how that disassembly is displayed, and then some other stuff to actually interact with IDA's kernel. So it's pretty complex to do. Binary Ninja is a little bit easier. It's kind of in between. So you can subclass this architecture class, then you implement the instruction decoding, the instruction semantics, the instruction printing. And if you implement the low-level IL translation part of it, you'll actually get all of the other ILs for free, which is pretty nice. So you're basically implementing the first level of lifting, and you'll get decompiler eventually out of that once they've added decompiler. So it is pretty powerful. And then you have to be able to apply the calling convention. So, like I said, adding a new processor in Ghidra will net you a decompiler for that architecture. It'll eventually do that for Binary Ninja. In IDA, it only gets you disassembly. And if you want decompiler support, you've got to reach out to the IDA Pro Hexrays folks if you want decompiler support, which is unfortunate. Community, we'll go through this real quick. It's important because RE tools are often poorly documented. It's great to work from examples or guidance, and it's easy to get lost and wasting time looking for an arcane fact here and there. For general RE, I tend to go to Reddit reverse engineering. Great way to discover blogs and things like that. There's now a reverse engineering Discord and InfoSec Twitter. If you start following your colleagues and I imagine even people in this room, you'll eventually branch out and run into lots of good InfoSec influencers who generally bubble up really important things that include reverse engineering. For Ghidra, it's very fledgling, not super active yet, but it's they of course have their GitHub repo. There's a few, I guess, fan sites. There's Ghidra.re, which is not official, but I think it's somebody who's mirroring some of the stuff from the actual Ghidra distribution so that you don't have to navigate to it on your own local machine. And you can actually interact with the Ghidra developers in GitHub and submit pull requests. I think it's been forked like over 1,400 times. Radar, in comparison, has been around for much longer. It's forked about 1,900 times. So people are really interested in Ghidra. Both IDA and Binary Ninja have their own respective communities. You've got to pay for access to the Hexrays forum, as usual. Hexblog is free. There's usually some good content there, but it's pretty sparsely populated. And there's, of course, 20 years of blogs and content that's out there for IDA. Binary Ninja has Slack. That's the most important one. I'll skip this one, but there are ways to interoperate between the two, export and import information. I'll leave that as an exercise to the attendees. So, in conclusion, use them all. If you can get them, great. Ghidra is really awesome. I imagine it's going to be improving very rapidly. I would love to see IDA Pro respond to this by opening up some more of their capabilities to the base level, and I think that will happen. All right. So we'll get through this trivia really fast, so we can switch over. This is for a Ghidra sticker. Where is Puff from? Hanali, you got it. You started singing the song in your head, didn't you? Okay, all right, so you get a Ghidra sticker. All right, next one. Who killed Viserion? The Night King. All right, that's Ghidra sticker number 2. What gold-loving dragon took up residence? Smog, yes, Smog, Smaug. Yeah. What dragon is also known as the World Eater? Alduin, yes. You've played Skyrim. All right, these are for the big prize. So if you got an answer up to now, you've got a Ghidra sticker. Who controls Dragonzord? Green Ranger. You got a kit. Well done. What dragon can you always spot in the north sky if you're in the northern hemisphere?
Draco.
I don't know whose hand was first. I think your hand was first. Or at least it was where I was looking. Draco. Correct. All right, and for the last kit, what's the name of the Draconic creature? This is pretty obscure. That attempted to take out Zeus. Anybody?
Ghidra.
Not quite. Who said Typhon? You did? All right, we'll split the kits. All right. Thank you very much, everyone. With 30 seconds to spare. All right.